The first rung of logic. At the end of our last section on talking about the data table files and working with them online, offline, and you can see that what's on the screen is exactly where we left it. We had you open up these three files, change the first bit of the first word to 1, download it, and as soon as you put it in the run mode, the input scan overwrote the 1 there in input file, data file I1, and changed it to 0 because that input was off. But the other two stayed the same. And then we had you go offline without saving, and you were right back looking at this. And that's kind of where we left it. A couple more things to say. One is these three data files right here are the most used data files in programming with RSLogix 500 because you always use inputs and outputs. I mean, if you don't take in information and put out information, meaning take in the state of sensors and control output field devices, well, you're really not doing anything, are you? And then you need internal data. In other words, you need bits that you can control with logic that are individual little decision-making pieces, like all the safeties are met, all the switches are turned off, all the sensors are seeing the cylinders back in the right position, that kind of stuff. So these three files right here, input, output, and then internal bits that aren't connected to I/O, these three are the most used in PLC programming land. And there is nothing unique between these three data files. If you disregard the source of how the data is changed, in other words, the input file, that's controlled by the state of the input devices when you're in the run mode. The output file is controlled by logic. And if there is no logic, there's nothing controlling it. The B3 data file, or any data file of that type, there's nothing there unless you have logic. Now we change values from the keyboard. So the only thing really unique about these three memory locations is how the data is altered. In the case of I1, it's altered by the state of the inputs. In the case of O0, it's altered by the results of the logic scan. And the B3 file, again, that is in the same boat, it's in the same category somewhat as the output file. So the state of all of the bits in the output file and all the bits in the B3 file are all controlled by logic, other than if you go in with your keyboard and change some, or if you have an HMI, like a panel view. Human Machine Interface, OIT, Operator Interface Terminal. Think of an Operator Interface Terminal, that is a screen, some people call it touch screen, HMI, as lookies and touchies. Things you look at and things you touch. In the previous days, it was push buttons and lights. And lights came on to indicate to the operator that the machine was in a certain state, and then the operator could push buttons to make decisions, to put it into the run mode, the manual mode, to continue to the next step. Those operator panels, as we called them, were lights and switches, lookies and touchies. Well, the screens are the same thing, except they're not hooked to I/O. So that operator interface terminal, it would have been connected to the O file and the I file. Inputs would have been the push buttons and outputs would have been the lights. In the old days, those lights and switches were connected to input and output I/O modules and controlled the input file there, and then your logic controlled the output file that controlled the bits that control the lights. Instead of attaching a panel view, an HMI, to the O and the I, and which you can do that, there are some panel views that you could treat as I/O, as remote I/O. But there's no reason to do that. You can connect them directly to any of the other files, B3, T4, C5, R6, N7, and F8, and so on. What you see on the screen, if you touch a button, it could turn on B3 10/5. It could turn on N7:101/4. The things that you touch on the screen turn on bits and files like the B3 file. So the only thing unique about these three data files is how the values are changed. And remember, these are the three most used files in programming. So the only other thing that's unique about them is their tag names. And remember, these are pre-declared variables. The I and the O, that's kind of straightforward, and they are associated with actual I/O hardware. So you will always have I/O hardware that's associated with the I and the O, or the 0 and the 1 file. All the rest of it, though, that's totally up to you. It has nothing to do with I/O. Another thing that's unique about these three files between them is the input and output files are determined by your I/O hardware. But B3 comes to you as a single element array, meaning B3, the file B3, comes by default as B3:0, one element, 16 bits, one integer. But it is the first integer or first element in an array that can be as high as 256. So if I click on properties, you see that we have elements 3. And the last element is B3:2. So we have 3 right there. If it's file 3, it's type B, we have 3 elements. But I could change this to 256 elements. Okay, I'm going to apply. Now you see the last one is B3:255. Remember, 0 is the first, 255 is the last. Now if you look down here, we'll have to OK this and come back and clear it up. So now I'm scrolling down through the B3. See, it goes all the way down to B3:255. Now, of course, we don't want that. So I'm going to come back down here to properties. You can't see that. I'm doing it off the screen. And I'll go back to 3 elements. Apply it. Now you see we're back to 3 elements. And we only care about the first word in this case. So now we're going to continue on and create the first rung of logic. Before I do that, though, I'll just close these. I can open these back up later. You know how to do that. You double click on it. If you're going to lock it on top, do it right away, because when you lock it on top, if you had already resized it, I'll do that. Let's say that, I wanted it like that. If I hit lock on top, bang, it's back to its default form. So I can always open it up, lock it on top, and move it around anywhere I want. We're going to create a rung of logic. Now, I'm not going to follow the lab project in the manual exactly. I'm just going to discuss what you did. There are 2 ways that you could create a new rung. Now, right now, see, it says 0, 0, 0, 0. That's rung 0. That's the end statement. The end statement is there to graphically tidy up the program file. It's not something you can touch or feel or do anything with. It's just there. It is actually something that will be in the machine level language, but you have no control over it. It's just there. So it's really not a rung of logic. It just marks the end. I can either drag down. Now see, nothing happened. Because where is my focus right now? It's right here. See how this one's a little bit darker? If I click over here, now the focus is over here. And if I drag it down, I'm dragging a new rung in tow. Notice that the little box is red. Now it's green, now it's red. If it's red and I let go, nothing happens. But if it's green and I let go, then it's in place. Now that's one way. Or I just hit the delete key. The focus is right here. I can just click on that and bang, it's down there. Now where it goes is determined by where your focus is. Okay? That's why drag and drop is more deterministic than click. if you double click on something, it will end up down here based on where your focus is. Maybe we'll hit that later. Okay, so there's two ways to get a rung down there. Now I need an instruction, a true if on. And notice that with the new instruction, it's highlighted. Now something that did not happen that may happen on yours, we'll go to properties and we'll go to miscellaneous, auto describe new instruction. I have that turned off simply because I don't want it up there. I'll put the descriptions and symbols in when I like. But I'm going to turn it back on and hit apply. Okay? Now the focus is still right here on that instruction, so I'm going to hit delete and do it again. So I'm just going to, the focus is right here, and now I'm going to type in an address. I'm going to type in something. Okay? There's really nothing to auto describe yet because there's nothing there. It's just an instruction, and that big question mark there says, okay, fine, you've got a true on, but what are you doing here? So I could make this an I or a B. And by the way, you could type it in or you can drag it in. So I'm going to double click on binary there, and I'm going to grab bit 7. Hold the mouse down. Look what happens when I get off of it. And I've got a red me up there. You know, something is going me, give it to me. As soon as it turns green, I can let go. Now I have that memory location assigned to that true if on. We'll close that. Double click, delete. And now we'll do something different. The focus is here when you see, I click on it. If I double click on it, it opens up the field to put in the address. Or if I just have the focus there, because this software is fairly smart, I'm just going to type in, and I'm going to show you the quick way. I want to put in the input 00, word 0, bit 0. So I'm going to type in I, which is a alpha character, then 0, which is a number, /0. Now, that's not really the memory location, but RS Logic is smart enough to realize that it can only be one thing. So when I hit enter, notice that it reformatted what I put in its complete form. I, which is I1, they don't show you the 1 because there's only one I file, and it's always 1. There's only one O file, and it's always 0. So they leave out the 1 and the 0. I colon, word 0, dot 0 / actually it's slot 0, I'm sorry. I colon slot 0 dot word 0 / bit 0. Now notice that the auto describe popped up here. As soon as I put in that address and hit enter, this popped up. So we could put in a address and a symbol. So I'm going to pause and do that. Okay, I typed in a description and it's assigned to the address, not the instruction. You can see up there you got a couple radio buttons, address, instruction. I never have used instruction. I just assign it to the address. Now let me tell you something about descriptions. That's what you're looking at right there. This is the first input bit used in this program. I put a period after it to make it a complete sentence, but that's totally unnecessary. And this is 3 lines, and the description can be 5 lines, 20 characters wide. The smaller you make the descriptions, the better, as long as they are descriptive. But what I wanted to say was, the description is not unique to that instruction or address. Even though you're pointing it at that address, descriptions, the same description could be used for more than one memory location. However, symbols have to be unique for that one memory location. Now I'm going to type in first. If I hit a space, it makes a space. We can't do that. You have to put an underscore, SWITCH. Notice it's lowercase. But watch what happens when I hit OK. See, it all goes to uppercase. You can't use upper and lower case for symbols, which are really aliases for the pointer I:0.0/0, which points to a numerical location in memory of which we don't know. In other words, I:0 is pointing to slot 0 and everything in memory associated with slot 0. It's pointing to that memory location. It's not the memory location itself. Although we're going to refer to I:0.0/0 as a memory location, always keep in mind it is a pointer. Tag name, pointer, variable. It's a pre-declared variable because you didn't declare it, you didn't create it, it was created for you. Now, first switch is an alias for I:0.0/0. You can also alias the whole word I:0.0, and then all the bits 0 through 15 will be first switch slash and then the bit number. We don't want to do that. That's too confusing. So let's just do it the way we did it in the manual. Now we need to add one more thing. Now the focus is on this instruction, right? Remember I told you if you drag it down, you can drag it to where you want it. But if you just double click on the next instruction, it'll go in based on where the focus is. So I'm going to put the focus back here to demonstrate that, and I'm going to double click on that guy. Not double click, I'm sorry, single click on it. You see where it went? It went right after the focus. Now I can take it and drag it over here. Look at all the red memes. You know, like little birds in a nest with the mouth open want the worm. So I could drop this worm in any one of these little memes here. Or I'll just leave it where it's at. I'll hit delete. Instead of the focus here, I put the focus here, then I click up there. Now it's in the right spot. You can't have the output style instruction over here in front of the input style. Now they're in the newer platforms, like with the hardware platforms that are supported by RSLogix 5000, you can do some things like that, but not in the older platforms. Okay, so there's our second instruction of our very first rung. Now I'm going to give it a memory location, and I'm going to do the same thing. I could double click on this and type it in, or I can just, as soon as the focus is there, then type in O0/0. That's just enough information for 500 RSLogix to determine what it was you wanted. O for output, and then the delimiter is the fact that you went from an O to a number, from a alpha to a numeric. You went from 0 to O. So that implies a delimiter. Slash, that's a delimiter, 0. If I put in O00, this wouldn't work. So I've got just enough information there, so when I hit enter, it restructures it to what it's supposed to be and gives me the opportunity to put in some information. I'm going to pause and do that. Actually, I had you put in B3, so I'm going to do B3 slash, and it was 0, and I told you to put in B3 slash 0 just like that. And then when you hit enter, it restructured it as B3 colon word 0 slash bit 0. Now I'll pause and add the text. Okay, I put in the text that I had you put in. I'm going to hit OK, and you'll notice that this will go to uppercase. Now, I do see a problem with both of these symbols. That's irrelevant because we're going to move on from this anyway. But first switch doesn't necessarily describe anything other than it's the first switch that we're using. Bit 0 of word 0, that really doesn't, that's even worse because that could be any bit 0 of any word 0 from any data file. It doesn't specifically, you know, the description does. It says first B3 bit used. So you know this is B3. You look at the pointer right here, B3, and you know it's B3. So really, it's not confusing, but it's not the best symbol in the world. Next, I had you verify the rung. There's 3 ways you can do this. You can verify the whole project. In other words, all the files, any ladder logic you got going on, you can verify all of it with that button. Or you can verify. Look, I'm up here where the green check marks are. That is verify all the program files. That's verify just the program file we're in, ladder 2. And you don't realize it yet, but you can have ladder 3, ladder 4, ladder 5, all the way up to ladder 255. So you can have a whole bunch of different program files, and we'll discuss that later. So verify all of the files, verify just the one you're in, or I can go here, right click, and I can verify this rung. And I'm going to do that. It would be quicker just to go up and click one of these two than to right click and then click something. So I showed you 3 ways that would affect the verification of this rung. You can use any that you like. A couple questions that I ask in the manual. Why are the instructions both highlighted? You see first switch and bit 0, word 0, both the instructions are highlighted. Well, they don't mean the same thing. Maybe indirectly you might want to argue that they do, but they don't. The true if on instruction addressing the bit in memory that I:0.0/0 points to, that bit is on in memory. It shows this is true. Now remember, we're offline. It's looking at the offline data file. That means that that bit was already on. And guess who turned that bit on? You did. Remember, we had these open, output 0, input 1, and B3. We turned on those first bits, right? We turned them on. And I could turn them off right now in 2 ways. I could right click, toggle the bit, that would toggle it off. Always remember, toggle bit in context here means switch states. I don't care for the word toggle. Typically a lot of people think of a toggle switch as 2 motions, but it's not. Or we could open up the input file and just change it back to 0, right? So that's why these both these instructions are highlighted with these bars. Now, if you've got a different color scheme on your computer, that's your business. But if you did this all in exactly the steps that we said, both these are highlighted for you. And that's why, because they're already on in memory. The true if on, that bit is on, so it's highlighted true. The other one is highlighted because it's on. So this is true false. This is on off. This is never true false, and that's never on off. This is true if on, and this is on. Then I had you add a second rung of logic, and I'll just quick repeat the process. Now I've got the focus right here, right? If I double click here, remember I showed you can click here and it'll put it down here because that's where the focus is. Or I can drag it down, or I can double click here and that starts a new rung. Okay, now let me do that again. If I double click here, it's going to open up a text editor, and I could put in a new rung. I could start typing in XIC space OTE enter. Whoops. XIC. My bad. Okay, see it puts in a true if on and an energized output. I'm going to delete that. Also, if the focus is here, I could just click on the first instruction. And RS Logic is smart enough to know I want a new rung and I want that instruction right off the bat. So, see, a lot of ways to do these things. Then I'll throw in the other one. Now I'm going to pause and put in the memory locations. Okay, when I added B3, I typed it in just the way I told you before, B3/0, and this all popped up. All said and done. It's not a new instruction. There was no description or symbol to add because we did it over here. Okay. Now this is new. Okay, we hadn't used this address before. So notice first light, got it all typed in, hit enter. Now, it's all in there, but notice that the rung is not verified. It's still in the edit mode, even though I know that the syntax is correct. Everything's correct. You still have to verify it. So you could right click here and click verify, or just go up here and click one of those and it's done. And then we had some questions in the manual. Why are the instructions all highlighted? Well, that's simple. The first two are highlighted because they are true if on instructions, and the memory locations that are pointed to by the input bit and the B3 bit, they're on. So these instructions are both true. They're highlighted because they're true. The ones on the other side, to the right, they're highlighted because those bits are on in memory. And there is no true or false business there. If I were to put in a true if off instruction and turn B30 off and then use the true if off B30, then that instruction would be true, but that bit would be off. You'll see as we go. So they're all highlighted because those memory locations are on or those instructions are true. At the left end of the rung, the instructions are true, so they're highlighted. The right end of the rung, the bits are on, so they're highlighted. How many instructions have we pointed to memory locations? Well, all four of those instructions point to memory locations, so the answer is 4. How many memory locations have we pointed instructions to? 3. That's because 2 of them point to the same memory location, that is B3:0/0. One of them writes to it and tells it it's on, and the other reads it and says that the instruction is true. Now remember, we're offline right now, so this logic is not executing. It only displays this way because our offline data table has those bits on. If we were online and input 0 was off, it would immediately overwrite that bit. It would be 0, that instruction would be false. It would turn off B30, so that would be off and not highlighted. And then the first instruction in rung 1 that reads B30 and it's off. Remember, we went online and input 0 turned off B30, now B30 is off. So this instruction is false and it would turn off output 0. Now, why is there 4 instructions but only 3 memory locations? So the quantities are not equal. The answer was no. And I gave you the answer to the last question, why 2 instructions point to the same memory location. Okay, this next step is very important because it depends on the state of your offline data table when you download. So we're going to download this, and keep in mind we've got 3 bits set to 1. The first bit and the first word of the I file, the B file, and the O file. So now we're going to download, and of course you have to have RS links all set up ahead of time, which you should. I always do system comms. I see the thing. This is telling me it's there. Found. 226 found. Download. Okay. I'm going from a 1400B to a 1400B. Yes. Current project settings do not match system settings. Would you like to replace project settings with new system settings? I'm going to say no, because I like what I have down there, even though what I'm downloading may be okay. I like what's already in there, so I'm going to say no. Processor is in the run mode, must be switched to the program mode to download. So yes, switch it to the program mode. Does the downloading. Change back to the run mode. This was very important. No. Okay, but I do want to go online. Let's do that again. Comms, system comms. There's my processor. Download. I could put in a comment. Okay, so we downloaded, but we don't want to go to the run mode. We want to leave with the program mode, and notice that this exactly matches what we had offline. So the difference between where we were at, a minute before and now is when we were offline, these 2 rungs, the graphics, were animated by the values in the offline data table. Now we are still in the offline project. There is no online project. The only thing that we've done is we've gone online with the data table that's in the controller. And because we downloaded those values, which we demonstrated in the last lab, into the controller, they're there now. Now watch what happens when I put it in the run mode. And that was something that we did in the book. So I'm going to go to the run mode, watch the state of these instructions. These are true, false, these are on, off. So go to the run mode. Instantly, this was false, turned that bit off, which made this false and turned that bit off. Pure and simple. Refer back to the section of the manual where you made note of the state of these bits when you went offline. Does the state match the state in which they were left? Well, it doesn't now. No, it did before you went into the run mode. So you could answer yes or no for that question. Well, yes, it did match before I went into the run mode. Now it doesn't. Does the current state match the state in which they were left before you downloaded the program and data files? That would be no. Okay, when you downloaded, they were on, now they're off. What was the state of these 3 bits in the offline view? They were all on. And then there's another question. We went to the run mode, and are the bits on or off in the online view? They're off. Even if they were on after you downloaded, but then when you put it in the run mode, they all went off. So they were all on before you downloaded, and then in the program mode, they were still on. You went to the run mode and now they're off. So in the offline view, they were all on. Next thing I had you do was go offline. So I'm going to go offline. Now we know that what we do here is going to determine what the state of the bits are in the offline mode. If you pick the wrong thing here, then you won't get the right process in your lab. So let's say no. What I'm trying to do is compare the online data file, which you're looking at right now. Notice that all the bits B30 and output 0 and input 0, they're off. Okay? So I'm going to say no. And then when I get offline, now I'm looking at the offline data table, and it shows these are true and these are on, right? So I want to firmly emphasize at this point, you got to be careful what you're doing when you go back and forth between online and offline. We also had a few more questions. Now this is in the offline view, okay? And it said, are the bits on or off in the offline view? In the offline view, they're on. Then I had you go back online. Now, I always tell you to do it up here in the book I showed you here, okay? This is fairly safe to go online from here because you've already got the tail pinned on the donkey, and there's no place you can go here but online with this controller you've been working with. But if you want to be safe, you could go to comms, system comms, and go online here. Okay, and I can also right here go who active go online, or just go online. So this go online is the same as this go online over here. So see, you say go online, upload, download. Look over here. Go online, download, upload. Different order, but same choices. So I'm going to go online. Once in a while you can have a problem with RS links depending on what else you're running on the computer, and I can see that it's having a hard time. If you get this message, say OK, and then go back to RS links and go to RSWho. We already had RSWho open, and it sees it through Ethernet, not through ABDF1, because we don't have that cable plugged in. So if that were the DF1 driver, you could go re-auto config it. Oh, here's the problem right here. Remember, it's exactly what I told you not to do, and I did it. Driver, ABDF1. It tried to use that driver, so that's the bad thing about selecting this. So I'll go to system comms, which is more deterministic, and I'm pointing with the Ethernet driver and saying online, and bang, I'm online. Okay, one more time, in the online data files, the bits, this is online now, the bits are on or off. They're off. And in the offline data files, the bits are on. Would you surmise that there are two different or two separate sets of data files? Yes, there is. Where do each of them reside? Offline, they reside on your computer or in your computer's RAM. Online, it's in the controller's RAM. Then I had you select Save from the floppy symbol here. You can do not prompt me for revision notes again. I'm going to turn that on because I don't type in revision notes unless I'm working on a very specific process for a customer. Warning, data table values may have changed. Do you want to upload? Yes, I do. Now remember, the last time we didn't save before we switched to the offline view. So what are you expecting to see this time when switching to the offline view of the data files? So we'll go offline now. I have you select offline. First, to ask you what you're expecting. Okay, and I don't know what your answer is, what you're expecting, but I was expecting them to be, for the bits to be off, because that's what we saved. So we saved our online image, but we are still looking at the online view. I had to go to offline. Are the bits on or off? They're off. Which view of the data files are you looking at? Well, you're looking at the offline. On one page, you see the exact same two graphics, and maybe that confused you. The one that still shows it in the remote run mode, the bits are off, and you're looking at the online. Then, in the next one, you're actually offline. Are the bits on or off? They're off. Which view of the data files are you looking at? You're looking at the offline. So I might have confused you there with that answer. When it was still said remote run here, you're still looking at the online. Now that says offline, you're looking at the offline. That ought to do us for right now. That did take a bit of time, but this is all extremely important material. Learn everything you can while you have the chance, while you've got the equipment right in front of you, the software right in front of you, and an instructor that can answer questions. Now, if you're watching this video from a disk, then you don't have an instructor standing there. But in our live classroom, where we actually use these videos as well, because we let people go at their own pace, and so if someone gets ahead, they can watch these videos instead of waiting for me to deliver this discussion.